Greetings, wonderful physics students, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with your homework, Unit 1, problems 8 through 11. So let's get started. So number 8, it says a high-performance sports car goes from 0 to 100 miles per hour in 8 seconds. Now, your numbers are likely different than mine, as this program generates random values, but I'm going to go ahead and just write the numbers that I have, right? So 0 to 100 mile per hour, and I think written right next to it in my homework version is 44.7 meter per second. They were nice and did that conversion for you in 8 seconds. So this vehicle went from 0 to 44.7 meter per second. So that's your change in velocity. Right, this 8 seconds right here, that's your change in time. And let's see, it says to calculate the car's average acceleration. So acceleration is the rate that velocity changes. Right? So when you calculate it, it's equal to your change in velocity over your change in time. And these numbers are just given in the problem here. So, you put your values in and get a number, and your units will work out to meter per second per second. I like writing acceleration units like that right now because I think it does a very decent job of kind of conceptually storing, if you will, what an acceleration is. For example, if an object is accelerating at 4 meter per second, right, it means that after 1 second, this thing's going to be moving 4 meter per second. After 2 seconds, 8 meter per second. After 3, 12 meter per second, and so forth. But again, this unit is also equivalent to a meter over second squared. Either one is fine. Part B, same car does a complete stop. So there's a velocity given and a time frame. Now, one thing to keep in mind here is that when you calculate the average acceleration, right, in Part A, the velocity was increasing. However, in Part B, the velocity is decreasing, and this has to be taken into account somehow with your answer. I'm not going to give that away. I'll let you think about how that would be done. Email me if you just can't get that figured out. All right, let me turn the page here and talk about number 9. I love this software that I use for this. Okay, let's see, a baseball is being thrown and it goes from 0 to 40 meter per second in 24 seconds. So you're given an initial velocity, and write these things down, right? 0 meter per second. You're given a final velocity, 40 meter per second. And we're given a time frame, 0.24 seconds. Now, your numbers may be different. Again, I use a program that randomly generates these, but it's important you know what these things are. So that is an initial velocity. In class, you might see me call that a v sub o, which is just an algebraic way of saying, initial velocity. This is some sort of final velocity. This is a delta t, a change in time. So it asks for acceleration. So you just have to know how to calculate acceleration. That's equal to your change in velocity over your change in time. And you're going to get this from these two numbers, right? And this is basically given in the problem. Very, very short problem here. Part B says, what is the acceleration in g's? All right, so the term g is kind of slang. And we haven't talked about this in, I think, our class as of yet, but we will very shortly. Gravitational acceleration is about 9.8 meter per second, meaning if you drop an object, any sort of reasonable size object, it will accelerate down at about 9.8 meter per second. So let me just kind of round this. This is approximately 10. I do this all the time in class, meter per second squared. So this idea of g, it's kind of slang term. If I had an acceleration of, let's say, 20 meter per second, you see how that's 2 times this? That would be called a 2g acceleration. Right? An acceleration of 50 meter per second squared, that would be sometimes called a 5g acceleration, and so forth. So basically, take your answer and divide it by the 9.8, and that will tell you how many g's it is. Okay, let's talk about number 10. Now, if you're wondering, will all the homework be this short? The answer is no. But number 10, Let's see, a rocket accelerates from rest to, at a rate of 64 meter per second squared. So always start these by writing down the data. And you really, and I haven't modeled this yet, I usually want people starting this by drawing a picture. So we have some sort of rocket. And it accelerates from rest. It's sitting on the ground. So my motion diagram for the rocket might look something like this. So here's my quick picture. Right, so it's starting from rest, so the velocity here is 0. The acceleration was given in the problem. In my problem, it says 64 meter per second per second. Now it says, what is the speed? So let's write this down. How is acceleration calculated? It's change in velocity over change in time. And they're giving you the change in velocity. And they also, within the problem, gave you a change in time. So just put those numbers in and you can calculate this. Now this represents the change in velocity. Because this thing starts from rest, whatever that change is will be the final velocity. Okay. When you do part B, when it says how long does it take to reach a speed of 7,700 meter per second, start by just writing out acceleration's change in velocity over change in time. The only difference is in part B here, they've given you a change in velocity. It's the same acceleration, and now that is the unknown. All right, let's chat a little bit about number 11. Okay, let's see. Initially stationary, a train has a constant acceleration of 0.6 meter per second per second. Start with a picture. I'm just going to do a quick deal and let that represent my train. Now the train is accelerating from rest. So the motion diagram for the train, and I'm just going to use a dot to represent the train, but the dots would be getting further apart as the train accelerates. Now my distances are kind of exaggerated here. That train's not going to be, traveling a full length of the train there after just a second or two, but now, we're given an acceleration, given in the problem. In my problem, it says 0.6 meter per second squared. So you might want to start by writing out, right? How is acceleration calculated? It's a change in v over a change in t. So, question A says, what is the speed after 36 seconds, right? So the acceleration is given in the problem. There's a delta t given. That will allow you to calculate this, your change in v. Part B, what is the time it would take to reach a speed of 38 meter per second? So when you do part B, you're given a V final. Now you're starting from rest, so the number you're given, it is a V final, but it's equal to a change in V as well, right? Because this thing's starting from rest. So in my example, that's 38 meter per second. You probably have a different number. So just write this formula out. Acceleration's change in V over change in t. This number's given. Acceleration was given earlier in the problem. And you're going to find this, the delta t. So that should be enough to get you through those homework problems. I hope that this helps you out. Have a great day.